Hello students, in this presentation we will discuss about mesh analysis, which is one of the very important topic in this course. So we will be dealing with two approaches for mesh analysis. So we will talk about the general approach which can be applied to any network. Then there is a format approach which can be applied only to networks with voltage sources. We will discuss what do we mean by general approach and what do we mean by format approach. So we will start with mesh analysis, the general approach. In general, see, first thing that you have to do in mesh analysis, we have to understand what do we mean by mesh. What is a mesh? So mesh is a window. So suppose you have a circuit in this pattern, there are two windows. So we have two meshes. Mesh means a closed path or a window. So if you have a structure like this, you will find that there are two meshes or independent closed loop. So what is a mesh? Mesh is an independent closed loop. So if you have a problem with this kind of a structure, then you find that there are three windows. That means there are three meshes. Mesh 1, mesh 2 and mesh 3. Suppose you get this configuration, again you can find that there are three windows. So this is mesh 1, so this is mesh 2 and this is mesh 3. Now suppose you get a bridge network. These kinds of networks are called as bridge networks. So here this is a closed path. So this becomes the closed path. So this becomes the mesh 1 and the mesh 2 is the upper triangle and mesh 3 is the lower triangle. So the meaning of mesh is a window. So here the number of windows is equal to the number of loop, and that is equal to the number of equations that we are going to form in the mesh analysis. In mesh analysis, we are going to use the Kirchhoff's voltage law. So all of you are aware, because in Kirchhoff's voltage law, if you have to write the Kirchhoff's voltage law equation, we have to consider a closed path. So in mesh analysis, we write the Kirchhoff's voltage law for each of the mesh or the loop. The mesh is also called as the loop. So here we call this as mesh 1 or loop 1. So here let us take this problem, that this problem has three resistance and two sources. So this problem has three resistance and two sources. So first thing is we will identify the number of windows. Windows means a closed path. So this is one window. So this is one window. So let me raise this. So this is one window. So this is our first window. So this is our window. So this is our mesh 1. So we have identified that it has the first window here and the second window is here. Window means a closed path. So here we find another closed path. So this particular problem or this particular figure has two meshes or the two closed paths. So here how many equations we have to write? We have to write two equations. But how are we going to write these two equations? We are going to apply Kirchhoff's voltage law to write the equation for each of the mesh. So what is the procedure for mesh analysis? We have to first identify the mesh. So I discuss how to identify the mesh. Mesh means the closed path or the window. So for each mesh, we have to assume the direction of the mesh current. See, the dotted lines shown here are called as the mesh currents. The dotted line here shown in blue color are called the mesh current. So in the first loop, we say that the current in the first loop is I1. The mesh current or the loop current is called I1. The current that we assume in the second loop is called as I2. So these are the currents. So this dotted line represents the direction of the current in the closed path. Now this is the first step. So we have to identify the mesh and then we have to choose the clockwise direction. We are assuming clockwise direction, but it is not necessary that we have to assume clockwise direction. But in this course, we will assume the mesh currents to be in clockwise direction so that it makes our analysis little easy and uniform for all of us. Then we have to mark the polarities. Then we have to write Kirchhoff's voltage law. And then we have to write the equation, solve the equation. After we solve the equation, we have to find out what is the current in each branch. Now I will explain this using an example. So these are the four steps. So first step is to identify the number of mesh. For each mesh, we will assume the current is in the clockwise direction. So this is our step 1. So after that, once you complete the clockwise direction, marking the clockwise direction of the mesh current, please assign the polarity to each element. Then apply Kirchhoff's voltage law and write the equation for the mesh. Now you will have two or three independent equations and you have to solve the equation and find the value of the mesh current. So I advise you to watch this video. If you are not aware of how to solve simultaneous equation, you can watch the previous video which is available in the link. That will help you to solve the equation that you have found. Now here the first thing that we have to do is assign mesh currents and polarity. So here the first step that I will do is I have found out that there are two windows. So once you find out there are two windows, then we have to assume the current in clockwise direction. See this, here they have assumed the current like this. So this is the direction of the current. So the current in this mesh is called I1. And in the window 2, again they are assuming the current in the clockwise direction. So this current is called I2. So this is our first step. The second step is go to this closed path or this particular window. Start with this element. Here no need to mark the polarity because it is the source. Since it is the source, the big bar represents positive and the small bar represents negative. But for resistance, you have to find out. In this resistance, you find that the mesh current is flowing like this. So the current entering point should be plus and the current entering point and the current leaving point is minus. And come here, when you come to resistance 3, you find that the mesh current I1 is flowing from top to bottom. So this point will become plus and the other terminal will become minus. So we have completed mesh 1. So now let us go to mesh 2. So in mesh 2, again we'll start from here. So when you start from this point, we'll start from here. So here in the mesh 2, you find that this current is now, the mesh current I2 in resistance R3 is flowing from bottom to top. So this becomes positive and this becomes negative. When you take R2, you find that the mesh current is flowing down. That means this terminal will become positive and this terminal will become negative. For the source, you need not do anything because the terminals are already marked. So this completes the second step. But one thing that you have to be very careful. Now you find that for resistance R3, we have marked one side we have marked plus and minus and the other side we have marked minus and plus. This would be new to you, but this is the procedure. For each mesh, for each element in the mesh, we have to mark the direction according to the polarity. So R3 is common to mesh 1 and mesh 2. That is why it has two polarities. And in the red color is marked for mesh 1 and the green color is marked for mesh 2. So this is the second step. So this is the diagram with the polarities marked. So in this diagram, we show the polarity. So I explained how do you mark the polarities. So this is the very important step. How do you get? See here they have marked plus and minus on one side and minus and plus on the other side. How did you get this? I was explaining. Because when you consider the red color, the current is flowing from top to bottom. So this point becomes plus. So this point becomes plus and the other point becomes minus. When you consider the loop 2, the current is flowing from bottom to top. So this point becomes plus and the other point becomes minus. So what is the point? So I will again tell you these two steps. What is the first step? The first step is to mark the current in the clockwise direction and to write the current. If there are two loops, you have to identify the windows and write the current. Assume the current in clockwise direction and write the current as I1. Then what is the second step? Go to the first closed path or the first window and mark the polarities for each and every element present in that loop. Repeat this for the other loops. So this completes the first step and second step. These are the two important steps that we are going to follow in the mesh analysis. Now let us take this circuit and then we define and then we are supposed to solve this and find the value of the currents I1 and I2. So here what we are trying to do, we are trying to find out what is the value of the current, mesh current I1 and I2. So we have already completed the first two steps. So what is the third step? The third step is to write the Kirchhoff's voltage law equation. How do you write Kirchhoff's voltage law equation? We are going to start from this point and we are going to move element from element, minus to plus. So it is voltage rise. So it is plus go to the next element. Again the polarity is positive to negative. See here, positive to negative. That means it is a drop. So first put negative sign. So what is the drop? Drop is the product of current into resistance. So in resistance R1, what is the current flowing? In resistance R1, the current flowing is I1. So we have to put 2 times I1. Now come to the next element. What is the next element? Next element is R3. Now R3 also the polarity is positive to negative. So positive to negative means it is a drop. So we have to put minus. What is the value of the resistance? The value of the resistance is 4. And we have to write the current. Now while you write the current, you find that in resistance R3, 2 currents are flowing. 2 mesh currents are flowing. Now we are working with mesh 1. So first to find the direction of the current I1. I1 is flowing from top to bottom. So it is positive to negative. So we have to write I1. And if you take the next current, what is the next current flowing? I2 is also flowing, but it is flowing in the opposite direction. I2 is flowing from bottom to top. So we have to subtract these 2 currents and write. So here the current flowing in resistor R3 is I1 minus I2. So this is very, very important. How did you get I1 minus I2? First, why did you write I1? Because we are working with mesh 1. So we have to write the current I1 first. Why did you write I1 minus I2? Because 2 mesh currents are flowing in this resistance R4. I1 is flowing from top to bottom and I2 is flowing from bottom to top. Their direction is different. So we have to subtract the current and write it. With that we complete all the elements. So this equal to 0. So this is our first equation. So we started at point A, we move in this direction, clockwise direction, and we completed at point A. Now come to the second equation. Let me change the color. Now for the second loop, again you start from point B. So now we are in mesh 2. So we will start from point B. So if we start from point B and move upward, so you find positive and you find negative. So positive to negative means drop. So what is the drop? So minus 4 into, now you are working with mesh 2. So you have to write I2 minus I1. So here there are 2 currents flowing. So one current is I2 and another current is I1. They both are in the opposite direction. So here we have to write I2 minus I1. So see here we write I2 minus I1, but here we write I1 minus I2. Why? Here we are working with mesh 1. So we have to write I1 first. Here we are writing the equation for mesh 2. So you have to write I2 first. Now why are you putting this minus sign? Minus sign is because both these currents are flowing in the opposite direction. So now come to the next element, plus to minus. So again drop. So minus 1. What is the current? Only one mesh current is flowing and that current is I2. So minus I2. Now come to the next element, positive to negative. So drop. Minus 6 is equal to 0. So these are the 2 equations. Why did you get 2 equations here? You get 2 equations because there are 2 meshes, mesh 1 and mesh 2. So if there are 2 meshes, you will get 2 equations. How did you get the mesh equation? We are applying Kirchhoff's voltage law to each of the mesh. That is why we get 2 equations. Now after you write the equation, what are you supposed to do? You are supposed to solve the equation and try to find out what is the value of I1 and I2. So this is our next step. So let me teach you that one. So I'll show you how to rearrange this equation. So this equation I explained to you. This is the Kirchhoff's voltage law equation for loop 1. So we are starting at point A. We are moving from one element to one element. For voltage rise, positive. Voltage drop means negative. So this is the idea. You have to write the voltage. Now why here I1 minus I2? I explained to you. I1 minus I2 because if you take the 4 ohm resistor, there are 2 currents flowing. On the left side of 4 ohm resistor, current I1 is flowing. On the right side of 4 ohm resistor, current I2 is flowing, and they both are flowing in different directions. That is why we put the minus sign. Then we have to write the loop equation for the second loop and we get this equation. Now after that we have to simplify this equation. Now from here we are moving here. So from here we are moving to this point. So how did you write this equation? Here loop 1, we are just expanding, plus 2 minus 2i1 minus 4i1 plus 4i2. We are just removing this bracket and expanding the equation. Now how do you write the equation 2? Minus 4i2 plus 4i1. Why plus 4i1? Because there is a minus sign here and there is a minus sign here. So we write these two equations, and then we are further simplifying. We are adding these two terms and we are writing it as 6 times i1. Then when you come to the next equation, you find i2 here, you find i2 here. You are combining this and making it into one term. So here you get this simplified equation. Now this equation here is not in standard form. What do you mean by standard form? Standard form means these constants have to come to the right side of the equal to sign. So please bring this plus 2 to plus 2 to the right side of equal to sign, it becomes minus 2. Bring this minus 6 to the other side of the equal to sign, it becomes plus 6. Now we have these two equations in the standard form. Now what is our next step? Our next step is to solve these two equations. How to solve these two equations? By the method of determinant. So this is one of the easier method to solve this equation. So how do you do this? First, I have already told you. Now let us take this equation. So I am taking these two equations. Now I am going to take this two equation and I have to find out what is the value of I1 and I2. So this is our step. So I1 and I2 are the mesh currents. So what is the first thing that you have to do? The first thing that you have to do is you have to start from this matrix. So what are the variables that we are interested in? I1. So first write I1 and I2. So what is the next step you have to do? So you know that this is called equation 1. This is called equation 1. And this one is called equation 2. So what you have to do? The row corresponds to equation 1. The first row corresponds to equation 1. The second row corresponds to equation 2. Anyway, if you watch the video, that the link given in the slide, you will understand this technique. I have already explained this. The first column corresponds to I1. The second column corresponds to I2. The column to the right of the equal to sign corresponds to the constant. So let us take equation 1. Do you have the term I1? Yes. What is the coefficient? Minus 6. So write minus 6. Then what is the coefficient of I2? 4. Then what is the constant? Minus 2. Then go to the next equation. What is the coefficient of I1? 4. What is the coefficient of I2? Minus 5. What is the coefficient of the constant? Okay, constant is 6. So this is how you write the equation. See here I have written this equation. Now I just taught you this equation. Now how do you find I1 and I2? The first step is to find delta. What do you mean by delta? Multiply these two numbers and then subtract the product of these two numbers. So minus 6 into minus 5 is 30, minus 4 into 4 is 16. So delta is 14. So this is the first step. So how do you find I1? I1 is equal to delta I1 by delta. Now what do you mean by delta I1? Delta I1 means remove the column I1 and replace that column with a constant. Take this constant and replace it in this position. So you have to remove minus 6 and 4. Remove minus 6 and 4 and replace it with minus 2 and 6. See here. So this is called delta I1. Delta I1 means remove the column corresponding to I1 and replace this column with the constant. After that the procedure is same. Multiply these two numbers. Minus, you can see the minus here, minus these two numbers. So you will get minus 14. Now what is the delta? Delta is the denominator. Denominator we already found out. Denominator is 14. So the 14. So the answer is minus 1 ampere. So I1 is minus 1 ampere. Now what about I2? I2 is delta I2 by delta. Now what do you mean by delta I2? Delta I2 means remove the column corresponding to I2. So here please remove this column. Remove this column and replace it with this one. So when you replace this, you will find that you will get minus 2 and 6 here. and then follow the same procedure. Multiply these two numbers minus these two numbers. So you will get minus 28 by 14 minus 2 amperes. Now, how do you check whether our answer is correct or not? This is very, very important. You can very easily check whether your answer is correct or not. Take the value of I1 and I2 and substitute in this equation. So, minus 6 into I1, that becomes plus 6. Plus 4 into I2, that becomes minus 8. So, 6 minus 8 is minus 2. Yes, these values are satisfying my equation 1. So, my answer is correct. Please check the second equation also. 4 into minus 1 is minus 4. What is that? Is I'm substituting the value of I1 and I2 here. I found out I1 and I2, my values are here. I'm just substituting in that equation. Plus 10 minus 4 plus 10 is equal to 6. So you have to substitute your value in both the equations and you find that both the equations are satisfied. So my answer is correct. Now the next point of discussion is why do you get a minus sign here? Why do you get minus sign here? This is a very important question. What does this minus sign indicate? See, while we are doing mesh analysis, we are making an assumption. We are assuming this current is in clockwise direction. It's only an assumption. It is not correct. Because we don't know the direction of the current, we are assuming all mesh currents to be in the clockwise direction. But when you get the answer as negative, what does it mean is our assumption is wrong. Our assumption that I1 is in the clockwise direction is wrong. So I1 is actually flowing in the anti-clockwise direction. Now why I2 is negative? I2 is negative because our assumption that I2 flowing in clockwise direction is wrong. But the answer 2 is correct. The minus indicate our assumption is wrong. So I2 is also flowing in anti-clockwise direction. So here this is explained here. This is our assumed direction. We assumed the current is flowing in clockwise direction. Our assumption is wrong. So what did we get? We get this current as minus 1 ampere and this current as minus 2 ampere. So this is what we get, the answer. Now what do we do? We can now, since we have got the answer, we know that these directions are wrong. So we can, this you see here, now I have marked the current in anti-clockwise direction and removed the minus sign. Same way I have marked this current in anti-clockwise direction and removed the minus sign. Why I removed the minus sign? Because now I know that my assumption is wrong. So I am marking the actual direction of the mesh current. So these blue color indicate the actual direction. You see it is in the clockwise direction. The next important thing in the mesh analysis is how to find the branch current. These are called branch currents, these red color arrow. How did I get is 1 ampere? Please go to this figure. So in which direction is I1 flowing in R1? I1 is flowing like this. See, we are here, the current is flowing in the anti-clockwise direction. So you'll find that the current I1 is flowing like this. So what is the value of I1? I1 is 1 ampere. So what is the current flowing in R1? So we can write the current flowing in resistance R1 is equal to I1. So what is the value of I1? I1 is equal to 1 ampere and this is the direction. Direction is also marked by red color arrow in the figure. So this is 1 ampere. So now let us go to R2. Now let us go to resistance R2. Only one mesh current is flowing in resistance R2 and you find the current is flowing in this direction. So what is the current IR2? IR2 is equal to the mesh current I2. Mesh current I2. So what is mesh current I2? Mesh current I2 is 2 amperes. So what is the value of the current flowing in R2? I2 is equal to 2 amperes. So this is 2 amperes and this 2 amperes is marked in the figure here. So this is the 2 amperes. This is marked and this 1 ampere is also marked in the figure. Now the point is how to find the current IR3. How to find the current in the resistance R3. So please go to the diagram. Please go to this diagram. You will find that in resistance R3 two mesh currents are flowing. I1 is flowing from bottom to top and I2 is flowing from top to bottom. These two currents are in different directions. So you have to subtract the current. Now compare these two currents. I1 is 1 ampere and I2 is 2 ampere. So which current you have to write first? I2. Why we are writing I2 first? Because the magnitude of I2 is greater than I1. So 2 minus 1. So what is 2 minus 1? 1 ampere. Now because two currents are there, which direction you will assume? You have to take the direction of the current whose magnitude is more. Here I2 is more than I1. So we have to take this direction as the correct direction. So this is the direction which is marked in the figure. So this completes the question. So here we have found the mesh current. After finding the mesh current, we have found out what is the current flowing in individual elements. Now after this, very easy. Suppose I ask you what is the voltage in resistance R1. It is very simple because you know the current and you know the resistance. You can directly find the voltage in resistance R1. What is voltage in resistance R3? You can apply Ohm's law. What is the voltage in resistance R2? You can apply Ohm's law. I can ask you for power. Power is I squared R and you can solve it. So the idea is if you are able to find the branch currents, you can find the voltage by applying Ohm's law, and you can find the power in each component by using the formula for power. Now the same question, but the step 1, step 2, step 3 are all the same. Suppose you are not able to understand this determinant, you can also use this method. So one, I have already taught you this problem with the determinant. Determinant means our delta I1 by delta. If you are not able to understand this, you can take these two equations, multiply the first equation by 4. Multiply the second equation by 6. Then you get two equations, add them together. Then you can find the value of I2. This is your basic maths. Then after you get I2, please substitute the value of I2 in one of these equations. And you will get the value of I1. So whichever method you are able to understand, please follow that method. Both the methods will give you the same answer. Now let us solve the next question. Here they are asking you to find the branch current through each branch using mesh analysis. Branch means here you have three branches. This is called branch 1, this is called branch 2, and this is called branch 3. So they are asking you to find what is the current in each branch using mesh analysis. So what is the first step? First step is to identify the window. So here there are two windows. After you identify the window, assume the current in clockwise direction. So this is I1 and I2. When I say assume, you have to understand our assumption can be right or wrong. If our assumption is right, you will get the answer as positive for the current. If our assumption is wrong, you will get the answer as negative. So you have to be very careful. So we are assuming the current as I1 and I2 which is flowing in the clockwise direction. After we assume, we mark the polarity. Why is this point positive and this point negative? Because according to our assumption, the current is flowing like this in resistance R1. So this point is plus and this point is minus. Why in R2 this point is positive? Because the current is flowing from top to bottom in the mesh 1. Come to mesh 2. Why do you put positive sign here? And according to mesh 2, the current is flowing up. So this point is plus and this point is minus. And why is this point plus? Because in R3 the mesh current 2 is flowing down. So this point, top point becomes plus and the bottom point becomes minus. Remember, the polarity is very important. If you make a mistake in the polarity, your final answer will be wrong. So marking polarity is an important step. After we mark the polarity, we have to apply Kirchhoff's voltage law to loop 1. So let us start from this point A. Minus to plus is voltage rise. So plus 5. Now drop. Plus to minus. Drop means minus sign. What is the voltage drop? Product of resistance into current. So resistance is 1 ohm. Current is I1. So 1 into I1. Then again go to the next element. Next element R2. R2 you have to be careful because two currents are flowing in R2. So minus because it is a voltage drop. So it is flowing, the current is flowing from plus to minus. We are in loop 1. So the current is flowing from plus to minus. So it is voltage drop. So we have to put negative. Product of resistance into current. Resistance is 6. Why I1 minus I2? Because we are in loop 1. We have to write the current I1 first. So there are two currents in this resistance. These two currents are flowing in different directions. So it is I1 minus I2. So come to the next element, plus to minus. Plus to minus means drop. What is the drop? Minus 10 equal to 0. So this completes the first equation. How to form the second equation? Go to loop number 2, start from the point B. So minus to plus, voltage rise. So it becomes plus 10. Go to the next element R2. Now we are in mesh number 2. So we are moving from plus to minus. So it is again drop. So minus. What is the drop? Product of resistance into current. Resistance is 6. There are two currents flowing. Why we are writing I2 first? Because we are now working with loop number 2. So I2 minus I1. Please go to the next element. Plus to minus. Plus to minus means drop. Minus. So minus 2 into I2. So we have completed the equation for Kirchhoff's voltage law. We write the equation. Then we take the first equation, we combine the terms together. This is minus I1 minus 6 times I1. So we combine these two terms and we get minus 7 times I1. Then we write the format in the standard form. 5 minus 10 is minus 5. So bring this minus 5 to the other side of the equation. To the right side of the equal to sign, it becomes plus 5. So we are writing the equation in the standard form. Now these are the two equations. And I am representing the two equations in the matrix form. I am not going to repeat this. I have done this many times now. You should be aware. So I am just representing these two equations in the matrix form. After you have the matrix form, we can use the method of Cramer's rule or the method of determinant to solve this equation and find the value of I1 and I2. So how to find I1 and I2? I1 is delta I1. So this is called delta I1. So the formula for I1 is delta I1 by delta. So delta I1 by denominator is called delta. So here they are directly writing it. So what is delta I1? Remove the column I1. So this you have to remove minus 7 and 6 and replace it with 5 and minus 10. So you will find that they have done doing this. They solve, they get the answer as positive. What does it mean? That means our assumption is correct. Now go to I2, repeat the same step. This numerator is called delta I2. What do you mean by delta I2? Remove the column corresponding to I2 and replace it with a constant. So delta I2 divided by delta, you get the current as 2 amperes. So our assumption that the current flowing in clockwise direction is correct. Now we have to find the current in each of the resistance. So let us go to resistance R1. Now in R1 only one current is flowing, that is I1. So what is the current flowing in R1? You can see the direction here. This is the red color indicates the direction of the branch current. So in resistance R1 or in this branch the current flowing is 1 ampere. Now let us go to branch number 2. In branch number 2 or we will go to branch number 2. In branch number 2 you have resistance R2, but you find that there are two currents flowing. I1 is flowing in this direction and I2 is flowing in the other direction. So I1 is 1 ampere and I2 is 2 ampere. So we have to subtract the current. Why we are subtracting? Because they are in different direction. So the answer is 1 ampere. But what about the direction? Direction we have to compare I1 and I2. Which is bigger? I2 is bigger. So here you see the arrow mark corresponds to the I2 direction. So that is why the arrow mark is like this. And what is the current here? 1 ampere. So this is 1 ampere. Now come to the branch number 3, or I want to find the current in resistance 3. The current in resistance 3 is nothing but the mesh current I2. So the current here is 2 amperes and there is no confusion about the direction because there is only one current. So this is the final analysis. So if I rub the unwanted things, so you will find the answer as written here. So this is our answer. So what is the current in the first branch? 1 ampere. So this is the current in the first branch. So what is the current in the second branch? It is 1 ampere. So it is moving up. What is the current in the third branch? It is moving down. So this is how you solve the problem. So now let us take this question. This is our next question. Again they are asking you branch current. So you have to understand the concept is we are using mesh analysis, but we are going to find the branch current. So here also you have three branches. This is our branch 1. The middle portion is called the branch 2 and the next portion is called branch 3. So we have to solve the problem by mesh analysis and find the branch currents. So let us solving it. So how many windows are there? Two windows. So this is window number 1 and this is window number 2. So in each window we are going to assume the current. Assume the current is clockwise direction. So the mesh current in loop 1 is I1 and mesh current in loop 2 is I2. We have assumed the direction. Then we mark the polarity. See here I am marking the polarity plus to minus. But when you come to R2, you will find that there are two polarities. I have explained this concept many times now. So plus to minus, because to the left side of R2, mesh current I1 is flowing. To the right side of R2, mesh 2, I2 current is flowing. So that is why the polarities are different. I1 is flowing from top to bottom and I2 is flowing from bottom to top. So these are the polarities. So this is the important step, marking polarity. So we have completed step 1, 2 and 3. Now we have to write the KVL equation. Start from point A. So plus to minus, drop. So minus 6. Go to the next element. Again plus to minus. So this is the element. Plus to minus, it is resistance. So product of current and resistance. So minus because it is a drop. The value of resistance is 2. There is only one mesh current flowing and it is I1. So go to the next element, plus to minus. Plus to minus means drop, minus 4. Then go to the next element, you have to be careful, minus because we are in loop 1. So we have to follow this polarity. So plus to minus is drop. So minus, what is the resistance? 4. And what about the current? Two currents are flowing. They are both flowing in the opposite direction. We have to write I1 minus I2. Why I1? Because why we are writing I1 as the first term? Because we are working with loop 1. Now please write the equation for loop 2. In loop 2, we have to start from the point B. So when you start from the point B, again plus to minus is drop. But now we write it as I2 minus I1. Why we write it as I2 minus I1? Because now we are working with loop 2. So you have to write the current I2 as first current. So I2 minus I1. So plus 4. Why plus 4? Because we are moving from minus to positive. Minus to positive means voltage rise. So plus 4. Then it is voltage drop, minus 6 into I2. And again voltage drop, minus 3. So now we have formed the two equations. Simplify the equation. Now you get the simplified equation. After you get the simplified equation, convert it into the matrix form and use the method of determinant. Now when you use the method of determinant, we get the answer as negative. What does it mean? Our assumption is wrong. We have assumed current I1 is in the clockwise direction. That is wrong. I1 is flowing in the anti-clockwise direction. Same way, I2 is assumed in clockwise direction and that assumption is also wrong. I2 is also flowing in anti-clockwise direction. So here, when you come to here, we are interested in finding the branch currents. We have to find the branch current. So IR1 is equal to I1, but I1 is negative, which indicates our assumption is wrong. So actually the current is flowing from as shown in the diagram. So the current is not flowing like the direction of I1. I1 is flowing like this. The current is flowing like this. And what is the current? Current is minus 2.18. What do you mean by minus 2.18? Our assumption is wrong. Same way, if you consider I1 minus I2, again you get the sign as negative. So our assumed direction is wrong. So this direction is shown here, but the arrow mark corresponds to minus 1.41. Now in I3, the value is minus 0.77. Minus 0.77 means this is the arrow mark, and here the current is minus 0.77, which is wrong. So what is the correct direction? Correct direction is opposite to the direction of the current shown by the mesh. So here, if you draw this arrow mark along the direction of the mesh current, you have to write it as minus 2.18 ampere. So here it is minus 2.18 ampere. So why minus? Because our assumption is wrong. Actually the current is not flowing like this. The current is flowing in the opposite direction like this. So this is the idea. So this is what you have to understand. How to find the branch current, you have to be very careful. If you have a negative sign, this negative sign indicates that the current is opposite to the assumed direction. Now here all arrow marks. In this diagram, all red color arrow marks are drawn in the direction of the mesh currents. So you have to be very careful about how do you understand this concept. Now let us come to format approach. Format approach is very easy. Here what we can do is we can skip the step that we need not write any Kirchhoff's voltage law equation. Only we have to understand two rules. Now what do you mean by two rules? One rule for diagonal element. All of you know in a matrix we have diagonal element and off diagonal elements. If you are not able to catch this concept, again watch the video how to solve simultaneous equation. I have given you the YouTube link in the previous slide. You can watch that one. So in a matrix, so if you draw a matrix, so all elements where the row index and column index are same. So these elements are called diagonal elements, and all other elements are called off diagonal elements. Therefore there are two rules. The first rule is for the diagonal element. First rule is very simple. Go to that mesh. In a mesh you add all the resistance in the mesh. So this is rule number 1. What is the second rule? Second rule states negative of the sum of all resistance connected between the two loops. So I will explain this using the diagram. So understand the loop. Negative of the sum of all the resistance connected between the two loops. So what is the rule for forming the column after the equal to sign? Equal to sign. So this is how you draw the matrix, correct? We are using this approach. So this first two rule, the first two rule is to form this matrix. The next rule is to form this column which is right of this matrix. How do you form the column? So it is again sum of the voltage sources. You have to take care of the sum of the voltage sources. And how do you put positive or negative sign? You have to put positive sign if the current passes from negative to positive, and you have to put a negative sign if the current passes from positive to negative sign, and if there is no source you have to put the value as 0. So these rules are very easy and I will explain it in the next slide. For example, here we are going to use the format approach. Format approach, no need to write any KVL equation. Directly we have to start from the matrix. So what is the first step that we have to do here? There are two mesh. So the first thing that you have to do is write the current here. Mesh current is I1 and I2. This is I1 and I2. And all of you should know that the matrix here corresponds to loop number 1. So this is 1 and 2. Please put the index. First row, second row. Same way, first column, second column. Now we are going to write this element 1, 1. So 1, 1 means please go to mesh number 1. Please go to mesh number 1 and follow the direction along the starting from A, follow the direction of current and come and end at A. So if we go to that, how many resistance are there? 2 and 4. So what is 2 plus 4? 2 plus 4 is 6. So you write 6 here. So why did you write 6 here? So because the first rule states sum of the resistance. So why you, so 1, 1. 1, 1 means please go to mesh 1, add all the resistances in the mesh 1. So 2 plus 4 is 6. So the next element that I am going to fill is 2, 2. So what do you mean by 2, 2 is the diagonal element. So what you have to do is you have to go to the loop number 2. So we have to go to loop number 2, and in that loop how many resistance are there? 2 resistance, 4 and 1. So we have to add the value. 4 plus 1 is 5. So what is 5? So we have to put 5 here. So now we have completed the diagonal element. Now we are going to fill this element. What is this element? First loop and second loop. Is there any resistance common between first loop and second loop? Is there any resistance which is common to both the loops? Yes, this resistance is common to loop 1 and loop 2. So what does the rule say? Negative of the resistance. So here what we are going to do is, here we are going to put a negative sign. Why we are going to put a negative sign? Because minus 4 because the rule states negative of the resistance. Now we are going to fill this element. How are you going to fill this element? Again, the resistance between loop 2 and loop 1. Is there any resistance between loop 2 and loop 1? Yes, 4 ohm resistance. So what you have to write here? Minus 4. Why are you writing minus 4? Because the rule states it is the negative of the resistance connected between the two loops. Now we have completed the matrix. Now here we are going to write this one. So this is very easy. Now go to loop number 1 and ask yourself, is there any source? Yes, we have a source in loop number 1. How is the current flowing? The current is flowing from minus to plus, voltage rise. So voltage rise means plus 2. So very simple, plus 2. Go to the next loop, loop number 2. Go to loop number 2 now. Is there any voltage source in loop number 2? Yes, we have a voltage source. How is the current flowing? Current is flowing from positive to negative terminal. Positive to negative terminal means drop. So minus 6. So this is how you form. So what we have done, given the question, we directly form the matrix using the rules given here. So these are the rules that I am following. So if you can understand this rule, you can directly form the matrix and you can start solving. No need to write the Kirchhoff's voltage law equation. So this method is very simple, provided you understand. Directly we can start with the matrix. After this is very simple. After this we have to just apply the determinant method and you will get the answer. So this is the format approach. So in another question, the next slide, I will explain the format approach for 3 loops. So here in this question, there are 3 loops and here they are asking you to find what is the current flowing through the 10 ohm resistor. The current flowing through the 10 ohm resistor is nothing but I3. So here there are 3 windows, I1, I2 and I3. So all polarities have been marked. So we have completed the first 2 steps. Now we are going to directly write the equation, format approach. So how do you start the format approach? First we have to write this I1, I2, I3. I1, I2, I3. So first write I1, I2, I3. Why you are writing I1, I2, I3? Because there are 3 meshes. So we have to write I1, I2, I3. Then here mark the column and row numbers 1, 2, 3. Then here you mark 1, column 2, column 3. So first we are going to fill these 3 numbers, diagonal element. First we are going to fill these 3 elements 1, 1, 2, 2 and 3, 3. So how do you fill 1, 1? Go to loop number 1. Add all resistance in loop 1. So this is 8, this is 3. So what is the value? 8 plus 3 is 11. So we are going to write 11 in this place. So please write 11. Now we are going to fill this element. How do you fill this element? Go to loop number 2. Add all resistances is loop number 2. 3 plus 5, 8. 8 plus 2, 10. So here we are going to write 10. So this is 2, 2. Now what do you do for 3, 3? So you have to fill this element. So go to loop number 3. So find the resistance. So this resistance is in loop number 3. This resistance is loop number 3 and this. So 10 plus 8, 18 plus 5, 23. So now we have completed the diagonal element. We are using rule number 1. We have to just add all the resistance in the loop and put it directly there. Now we are going to fill this element 1, 2. So what do you mean by 1, 2? Go to loop number 1 and go up to loop number 2. Is there any resistance common to both the loops? Yes, this 3 ohm resistor is common to both the loops. So what we have to write? We have to write minus 3. Why minus 3? Because in the formula, in the rule, it says negative of the resistance connected between the 2 loops. Now let us go to the next element. So in the next element, we are going to consider 1 and 3. So go to loop number 1. Go to loop number 1 and go to loop number 3. So these are the 2 loops. Is there any resistance common between loop 1 and 3? Yes, this 8 ohm resistance. So here what we have to write is minus 8. So this is minus 8. So the next element that we are going to write is 2 comma 1. So what we have to do, go to loop number 2 and loop number 1. So is there any resistance common between loop 2 and loop 1? So loop 2 and loop 1, is there any resistance common? Yes, 3. So what we have to write here, we have to write minus 3. So here you have to write minus 3. In the same way you can continue. So this point will be minus 5. So between loop number 1 and 3, I think this is minus 8, and between 2 and 3 it is minus 5. So we have completed the matrix. Now how do you fill this column? So go to loop number 1, because it belongs to, this row belongs to loop number 1. Go to loop number 1. Is there any voltage source? Yes, I have a voltage source, and the current is flowing from minus to positive. So that means plus 15. So here you have to write plus 15. So this is plus 15. So what about the next loop? Go to voltage, go to loop number 2. Is there any source? There is no source. So you can mark it as 0. Then go to loop number 3. Is there any voltage source in loop number 3? No voltage source. So you can mark it as 0. So without writing even a single equation, I am able to complete the matrix. So this is our matrix. So I was explaining how we are getting this matrix here. Now what we have to do, we have to solve this matrix and find what is the value of I3. So the first thing is we have to calculate the determinant. We have to first calculate delta. So take this matrix, repeat the column 1 here and repeat column 2 here. And then what we have to do, we have to fill up these elements. How did you get 2530? You get 2530 when you multiply these three numbers, you will get 2530. How did you get minus 120? When you multiply these three numbers, you will get minus 120. Then how did you get the next minus 120? When you multiply this, you will get minus 120. These formulas I have explained in the another video, how to solve simultaneous equation. Refer to that. So multiply these three numbers and write the value here. Now multiply these three numbers and write the value here. Multiply these three numbers and write the value here. Now use your calculator and you will get the value of delta as 1168. Now what is I3? I3 is nothing but delta I3 by delta. What do you mean by delta I3? Remove the column corresponding to I3. So what is the column corresponding to I3? This is the column corresponding to I3. Remove this column and replace with this. Replace the constant there. So you can find here I have replaced this one. Then what we have to do, again we have to use the same procedure. So first multiply these three numbers and you have to write here. Then multiply these three numbers and then write here. Then multiply these three numbers and write here. Then you have to put negative, negative, negative. These things are explained. So you have to multiply these three numbers and you have to write here. Then multiply these three numbers and you can write here. Then you can multiply these three numbers and you can write here. So you can solve it. You will get delta I3 as 1425. So 14 delta I3 is 1425. Delta is 1168. You substitute, you will get the current as 1.22 amperes. So format approach will save lot of time. So if nothing is specified in the question and if you thoroughly understand format approach, you can use the format approach. Now homework problems are there. Please try to solve the problems, and if you have a doubt, let us know. Thank you so much.